Welcome students to the part 4. Now in this we will be seeing the types of equilibrium. Now in the last video we have seen that a body is said to be in equilibrium if the net resultant of all the forces acting on the body fails to change its position or fails to change its state of rest or of constant or uniform motion. Now types of equilibrium, there are two types. One is static equilibrium, one is dynamic equilibrium. Now let us see static equilibrium. Now static equilibrium is for those bodies or those equilibriums when the body is in the state of rest. Now we will see different examples. See this first one, you can see this is a block kept on the table and there is force F1 which is pulling it this side and the force F2 pulling it to the right side. Now the F1 is equal to F2, only they are in the opposite direction, and that is why they are not going to make any net effect on the body. So this is a static equilibrium. Second, a book lying on the table. The book is exerting its force, its weight on the table, and table is giving the reaction force on the book. Now the book is not going to move on its own. Book is going to lie over there only. This is again equilibrium position. Static equilibrium. A beam balance where both the pans are balanced. Now suppose when you are weighing something and both the pans are having equal weight, they are balanced, they are in their state of rest and you cannot change that. So that is again a state of static equilibrium. Now coming to dynamic equilibrium, now this is when the bodies are in motion. Now a body is remaining in the same speed or constant motion, whether it is translational or rotational motion. If the speed is not changing, the speed is constant, we call it as a dynamic equilibrium. Example, a raindrop. Now imagine a raindrop which is falling from the clouds to the earth's surface and the speed remains constant. Now while it is coming down, there are many forces acting on it, the resistive force of the air, the buoyant force, everything. But in spite of that, the speed of the raindrop is not changing. That means the raindrop is remaining in the equilibrium position. Moreover, since it is moving, it is a dynamic equilibrium. The aeroplane is moving at a constant height. Okay, all of you must have done an air flight. Now you will never find the aeroplane going up and down very frequently. It is going to be constantly at one particular height. Here also the forces are balanced. That is dynamic equilibrium. You have a stone tied to a string and you are just rolling it above your head in a uniform circular motion. Here also you will find that though many forces are acting on this stone, but they are balanced by the centripetal force, and that is why it is having a uniform circular motion. This is again a state of dynamic equilibrium. Now take the motion of planets. Planets go or revolve around the sun. You have satellites revolving around the planets. You have electrons revolving around the nucleus. All these are uniform circular motion. They all are in dynamic equilibrium. Now what is the condition required for the equilibrium? Now for translational motion, for a linear motion, very simple, whether it is in the state of rest or it is in the state of a linear motion, the resultant of all the forces acting on the body must be 0. The second condition will come for the rotational body. The algebraic sum of the moments of all the forces acting on a body about point of rotation should be 0. That is, the sum of clockwise moments must be equal to the sum of anti-clockwise moments, so that when we add them, since the sign of one of them will become negative, it will be 0. And you know that we take anti-clockwise as positive and clockwise as negative. We have seen that in the first chapter. Now coming to principle of moments. Now what do you mean by principle of moments? Very simple. In state of equilibrium, sum of anti-clockwise moments will be equal to sum of clockwise moments. Now a physical balance or a beam balance works on the principle of equilibrium.